Thank you. Iterative procedures to highlight the formation of molecular aggregates of water molecules in pure perturbed water. Vittorio Elia and Elena Napoli. Let me thank Professor Pollack for kindly inviting us at this 11th Water Conference. But above all, I have to thank him for the astonishing discovery of the exclusion zone. Let me, some notable thinkers facing some new and yet unknown phenomena. I think we are living in such exciting adventure. When a thing is new, when a thing was new, people said, it is not true. Later, when its truth became obvious, people said, anyway, it is not important. And when its importance could not be denied, people said, anyway, it is not new. William James. Well, here I report the refusal letter by PNAS, a prestigious scientific journal, Impact Factor 9. The editor comment in red, please read, is clear as a clear example how the pathologic, I don't know how to, the pathologic skeptic work when we are in presence of a new. And here we can see the opinion of the editorial board of the journal Nature, which proves to be completely closed-minded regarding scientific innovation, even when supported by experimental evidences. Paraphrasing the statement of Galileo, and yet it moves, one may say, and yet it agrees. I hope you will excuse the disrespectful comparison, but this is the situation. Well, iterative procedures Iterative procedures is the means to highlight the formation of molecular aggregates of water molecules in pure water. We studied the effect of natural hydrophilic polymers, cellulose derivatives, or synthetic ones such as Neptune on water. The procedure consists of immersing this material in water for several minutes, then extracting it and drying it at room condition. We iterate the two steps several tens of times. The iterative procedure of drying and rehydrating procedures produce large variation of the electrical specific conductivity and pH. Now, let's start talking about our iterative procedures. Help, please, because I cannot move the. Who can help me for the computer? Non riesco a leggere quello che dovrei leggere.
Cosa devo fare?
Voglio sapere come faccio a far scrollare questo. Ok. Sorry. No.
Cliccare qui,
Basta cliccare qui.
Eccolo qua. Va bene così?
Ok.
Ce la fai?
Vediamo.
Io sto qui.
Ok. Now let's start talking about our iterative procedure. In the next slide, we will show how the iteration of simple drying and rehydrating Nafion change the properties of the solution. The perturbed water was obtained using these different protocols. A semi-diluted solution obtained through an iterative process of successive dilution and agitation. IFW, iterative filtered water, obtained through an iterative process of successive filtration through sintered glass filters, and iteratively nationalized water and iteratively cellulosated water, INW and ICW, obtained through an iterative process of successive drying and wetting of the Nafion or cellulose polymers. This presentation will illustrate these three different methods to perturb water. All methods produce very similar systems with quite similar properties. Now we talk about the effect of Nafion when produced INW, iteratively nationalized water, and hydrophilic cotton, ICWAC, on the supramolecular structure of water. Nafion membrane with a surface of 120 square centimeter were placed in a Petri capsule of polystyrene in contact with 10-50 milliliters of water. Thank you. Manual agitation is performed repeatedly so that the liquid laps against the membrane. The membrane is then removed from the contact with the liquid, and we can put back. Per farlo andare su?
Adesso per farlo alzare, siamo di là.
Okay.
Siamo lì?
Okay. And when we iterate this procedure, electrical conductivity systematically increases. The membrane is then dried and put back into the INW so that we can iterate. Sì. Sì?
Bisogna proprio cliccare qui, sennò...
Okay. And then we can iterate the procedure of drying and rehydrating the membrane. In the case of hydrophilic cotton, we use a chunk of similar site to the membrane one, and the manual procedure consists in dipping the piece of cotton in water and then removing it from the liquid and squeezing it. The cotton is then left to dry at room temperature and pressure. And all our measurements, as the measurements of Rumiana, we talk about Nafion with their techniques, is made without the presence of the polymers. You know, as many of you know, Nafion is a tetrafluoroethylene polymer with side chains bearing sulfonic groups. The hydrophilic sulfonic group, the hydrophilic groups. In the ICW technique, we employ stock hydrophilic cotton, the one for sanitary use, declared by the producer company as extra India pure cotton free of impurities. Nafion and cellulose are two polymers. You can see the formula of Nafion, very stable and practically insoluble. Okay. water, after the INW procedure using Nafion and or the ICW procedure using hydrophilic cotton, has deeply changed all its physical-chemical parameters compared to pure water. The physical-chemical parameters that change are pH, specific electrical conductivity, heat-mixing density, and so on. And the new physical-chemical properties appear, such as circular dichroism and fluorescence spectra. In the next slide, I will describe some of the physical-chemical properties of nafionized water and of cellulosited water using hydrophilic cotton, which are quite different from those of pure molecule water. They are very different from molecule water. Here we see the graph of pH as a function of the logarithm of electrical conductivity of nafionized and cellulosited water. Each point are different sample. The specific electrical conductivity, scroll, you. As you can see, the two physical systems follows two different trends between pH and logarithm of conductivity. Both trends are linear. Okay, you have a very interesting hand. Both trends are linear. The linearity, as told Rumiana in the precedent talk, the linearity is a symptom of the fractal nature of the aggregates. Please note how the pH is strongly acid for using a Nafion, the red line, while it is alkaline when using hydrophilic cotton. The difference highlights the extraordinary versatility of water when it interacts with hydrophilic surface, and also our poor knowledge of the behavior of water. Okay. The specific electrical conductivity increases for both nafionized and cellulosited water, and the increase of electrical conductivity is strongly affected by the iterative methods we have described. It is linked to both the number of molecular aggregates and to their size. The variation can reach 3 orders of magnitude or more. pH instead is influenced by the chemical affinity of the proton with the aggregates. If the affinity is strong, the pH is alkaline. If it is weak, the pH is acid. Okay. Here we present you the two very interesting variation. For iteratively cellulosited water, the electrical conductivity, when you apply the iterative method, varies from 1 in microsiemens and centimeter to -1, that is the electrical conductivity of pure water, to 6,600 microsiemens centimeter to -1 for the ICW. While for INW, the variation is 1,300 microsiemens centimeters to -1. Very large variation that cannot in any case attributable to presence of impurity or something this kind of variation. Still, pertaining the liquid state of INW, the next slide contains the first ever photograph of a molecular aggregate of water molecules of micrometric size. To obtain such images, nanospheres of polystyrene soaked in fluorescein are inserted in the liquid sample. The sample with the nanosphere is then illuminated using ultraviolet light. Finally, using optical microscopy, we obtain the following images. A remarkable, clear image of an aggregate is visible. This is an aggregation from nationalized water. The same happens for hideous, extremely diluted solution, and IFW, iteratively filtered water. For IC water, work is in progress. Molecular aggregates in the liquid phase can be seen. Sì, questa è la prossima. Ah, devo fare la prossima forse. Sì. Okay. As many of you will know, circular dichroism spectroscopy is a widely adopted technique in the study of biological macromolecules. And in this slide, there is a brief comment on the physical significance of circular dichroism. The CD spectra provides important information of the secondary structure of proteins, polypeptides, and DNA. The shape of CD spectrum provides information on the presence in solution of optically active polymers and their secondary structures, such as alpha helix, beta sheet, or random coil. Of particular note for us is the beta sheet spectrum that you can see in the red. Then, when we obtain a circular dichroism spectra like the red one, we must have information that in the water, in the liquid, is a macromolecule, and that this secondary structure is a beta sheet, such the one of polypeptide. The beta sheet spectrum, sì, la prossima allora, la prossima questa, sì. Okay, the beta sheet spectrum is this configuration of, in this case, of a normal biological polymer that have this movement, this secondary structure. Dichroism obtained, circular dichroism obtained of the various perturbed water, EDS, INW, and ICW, shows that the secondary structure of the polymer responsible of the circular dichroism is a beta sheet kind, whose shape is pictured in this slide. Naturally, in our case, the polymer does not contain neither carbon nor nitrogen atom, because we are working with pure perturbed water. Okay. Some clear example of CD spectra for INW. As mentioned in the previous slide, we are in presence of a CD spectra very similar to those of a biological macromolecule, such as a polypeptide, with a secondary structure or beta sheet. Of course, since our samples are pure water, from a chemical point of view, and not a biological macromolecules, we would expect to obtain flat spectra. It is an horizontal line. It is not so. We have this kind of circular dichroism spectra. In this case, we have three different spectra for three different INW preparation with different conductivity. And at high conductivity, we have a minimum more found. Ok, se cambia. Sì. Okay. A very surprising result, but at the same time, very satisfying for us. The INW and ICW samples produce very similar circular dichroism spectra, despite the very different pH of this solution. One is very acid and the other one is alkaline. In particular, both exhibit beta sheet secondary structure, similarities and peculiarities of these two different kinds of water. Okay. The circular dichroism phenomenon is found also in the case of EDS sample, the sample obtained with the method of homeopathic medicine, to be clear. This graph shows three circular dichroism spectra for three different active principles, whole at 12 centesimal Hahnemannian dilution. These dilutions are so extreme that they are universally recognized as nothing else than pure water. Also in this case, the secondary structure of macromolecule is a beta sheet kind. These spectra are very similar to each other, but also feature some differences. And now, another extraordinary finding. An additional physical-chemical methodology broadly used to characterize biological macromolecules is that of fluorescence spectra. We also employed it to study our sample of water perturbed with INW, ICW, and ADS procedure. Of course, since our sample are pure water from a chemical point of view, and not a biological macromolecule, we would expect to obtain flat spectrum. This is not the case. In this slide, we see the fluorescence spectra of three samples. The celluloside water in blue, the cellulosided in red, and extremely diluted sample in green. As you can see, fluorescence spectra that are, as you can see, we do get fluorescence spectra that are not flat. The similarity between the three perturbed waters and the biological macromolecules continue to surprise us. There is a feature found in all three spectrum, the presence of two maximums. Apart from that, there is a very large difference in both intensity and wavelength of the maximums. On this topic, Dr. Germano will provide many more details in his presentation tomorrow. These fluorescence spectra underline much better than circular dichroism ones the difference between the two kinds of perturbation techniques. In fact, the shape of fluorescence spectra of EDS, INW, and ICW are quite dissimilar. The circular dichroism ones are, on the contrary, very similar, all featuring a beta sheet secondary structure of these new macromolecules. Thank you. Let me focus now on the fluorescence spectra of EDS samples, extremely diluted solution, of three different active principles, all 12 centesimal and Hahnemannian dilution. It seems this measure is capable to distinguish between different active principles, as can be seen from the different shapes of Arsenicum album. Arsenicum album is red. Arnica montana is black, and Nux vomica, there is blue. It is a notable result, hints at the possibility of maybe in the future to be able to distinguish the nature of active principle in homeopathic dilution, a possibility that maybe could change the history of homeopathic medicine. Work is in progress. INW, ICW, and the NDAs contain macromolecules that behave similarly to biological macromolecules. Okay. The perturbed liquids contain 3 different macromolecules that behave similarly to biological macromolecules. The analysis of the chemical composition of the liquid does not detect organic or biological macromolecules, pure water. Okay. We are able to obtain solid-state sample of this macromolecule in solution simply by evaporating at room temperature and pressure a few drops of liquid, INW, IFW, or EDS. This is how solid-state samples are usually obtained in order to study them with technique such as atomic force microscopy. Another method to obtain a solid residue consists in removing bulk water using a freeze-drying procedure. Okay? This photo shows the solid deposit found after freeze-drying and iteratively nationalized water, one of the most striking examples in terms of quantity of solid. Okay? And also in this case, you can see a solid deposit after freeze-drying and iteratively cellulosated water. And in the third one, again, the same result using extremely diluted solution. Of course, the freeze-dry procedure on distilled water give no solid residue. A new solid material was obtained, whose chemical composition is hydrogen and oxygen. It is stable as solid at room pressure and temperature. Probably it is a new phase of water, the 5th. Perturbed waters contain macromolecules that behave similarly to biological macromolecules. Okay? In all important transition of life, we have to take a leap in the dark. Thank you for your attention.
Thank you very much for your interesting presentation. Now, are there any questions? Okay.
It's quick. Thanks, Professor Elia, for the great talk again. You showed aggregation, but could you tell us more about what type of forces would be modulating this aggregation? Again, with the like approach, we would expect more crystalline structures. So what kind of attractive force would be driving this aggregation?
Niente.
Thank you.
Di fare che cosa? Di? I don't know. Surely in the liquid there are molecular aggregates of water molecules. So it is changing dramatically, is chemical physical nature. But I have no information about the nature of the force. Yes. Pollack.
Thank you for a brilliant presentation. This is really amazing work. Question, when we spoke last time, you had done some preliminary mass spectrometry of the solid material. Have you done anything more to find out more about the atomic structure?
No. See? No. 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 Well, in the case of the new spectra of dichroism, circular dichroism, and principally of fluorescence spectra, the real possibility that we have wrong measurements is if inside this liquid there is a biological macromolecular or organic substances. So we made the MALDI technique with mass spectroscopy as detector to detect if there are some carbon or a piece of polymers or organic. There is nothing. It's pure water.
Okay.
Is there any other question? Yeah.
Hello? Is that solid that remains there, is that oxygen dihydride? Is it just water in a solid form?
Yes.
Powder?
Yeah. See. We start from a liquid that is, inside this liquid there is no organic compounds. There is no salts or so on, impurity of this kind, standing to the great values of the physical chemical parameters. And then in the case of circular dichroism or fluorescence spectra, this is not important. Also, if in the solution there is, is some salt, there is not important for this kind of analysis. Circular dichroism is not important if it is a buffer also. When you measure this kind of, you put salt and buffer in solution. Also for the spectra of fluorescence. So we are probably in presence of the fifth. The fourth is you. Mine is the fifth.
That's great. That's fantastic. Thank you.
Thank you very much for your presentation. Do you see any relevance of your result with the results of Wien law about so-called, they call it DNA water? That's the first question. And second, did you study the infrared spectrum of this residue as they studied?
See. Yes, many similarities. I hope that Montagnier give me his solution, and so I can study with our method if there is in solution some macromolecules. Okay, work is in progress. And the second one?
Infrared spectrum of this residue.
Yes, we made the infrared spectrum of this solid. It is flat. So probably the stretching of the wedge for the water molecules and the bending, obviously, is not possible because there is a polymer. Then there is no OH free, and the spectrum is flat.
Hey, Vitorio, very nice presentation. Question about the solid in any of the three forms. Can it be rehydrated? Does it recombine with bulk water?
Okay. Yes, you can dissolve the solid in water with some difficulty, but the best solvent is sulfuric acid, concentrated sulfuric acid. But it dissolves with some difficulty in pure water, and we have the same results before the lyophilization.
And so after that dissolving of the solid, if you re-lyophilized it, I assume the solid would come back, implying that you really do have a polymer-like substance. Is that right?
The lyophilization procedure?
No, a repeated lyophilization, the second time around after it's redissolved.
It is possible. I don't meet.
Okay, thank you.
Okay, I would have perhaps the last question, very short
Okay.
for you too, yeah. Do these aggregates have any electrical charge?
Work is in progress. In the Polytechnic of Naples, we give for colleagues some of this solid, and they must measure the electrical charge, but the time flow.
Okay.
The results not arrive.
Okay. So thank you again for your presentation.
Thank you.